Hey there, welcome back to another video. Thank you so much for watching. Today we're going to be talking you through 3/4 clutch pack upgrade options for 700R4s and 4L60Es. So if you're building up your 700 or 4L60E and you're working with any sort of application at all that's beyond factory spec, I would strongly recommend you invest in an upgraded 3/4 clutch pack. Reason for that is this is the single most pervasive, most prolific failure point in these units by far. It's not even close. I would say a distant second would be the sun shell. So 700R4s don't seem to have this problem quite as often in my personal experience as 4L60Es. For whatever reason, I don't know enough about the hydraulics to, really give concrete explanations as to why. And it could be sampling error too. Other builders that have done, many more of these than I have may tell you different, but about 70% of the 700s come in with 3/4 failure. The other 30% are for other reasons. But the 4L60Es, and it doesn't matter what year vintage, 93 to into production 2013, they're all the same in this regard. I would say no less than 90% of my 4L60Es that I've built come across the bench for 3/4 clutch pack breakdown or, just total abject failure. They just stop working. 4L60, as you know, is an electronically controlled transmission. It has electronic pressure control solenoid, shift solenoids, PWM solenoid, a wiring harness, TCC solenoid, pressure switch manifold assembly, and it's all controlled by a PCM and in later years a TCM. 700R4s are purely mechanically governed, and line pressure is controlled by the throttle valve system, and it works in combination, via a TV cable, plunger and sleeve, and a main throttle boost valve, and that works in tandem with the pressure regulator valve, boost valve, and the pump. So once you kind of set your cable, get your geometry and your adjustment correct with a 700, and you validated it through pressure testing, which you should always do, you're good to go for a long time. The 4L60Es, the longevity distributions all over the map. Sometimes they come in at literally less than 70,000 with a wipe 3/4. Other times folks report well over 200,000 miles on the factory unit, and it's still going, or when it comes in it's got a couple hundred grand on the clock. So it's luck of the draw in my opinion, but like I said, the recurring theme, the common denominator, and 90%, maybe 95% of them is 3/4 clutch pack failure. So we're going to delve into two examples, two options for you today for upgrading this clutch, beefing it up so that you can avoid this fate. Now, along the way, I'll also talk about other factors that contribute to these failures and things you can do to mitigate the risk that a failure happens to you on overhaul and that the 3/4 clutch pack lasts a very, very long time. But while there's a multitude of different products available, we're going to demonstrate two of them. One's going to be a factory option, the other is going to be from the aftermarket. So the factory option is going to be a 4L65E clutch pack. So those packs were installed in all the 4L65s and 4L70Es from the factory from 2001 through into production in 2013 or 2014. And the aftermarket option we're going to be demonstrating is going to be the Alto Power Pack. And those I've been using for the last 3, maybe 4 years or so, and I've had very good luck with them. And they come with a few different variants based on level and price. So we'll get into those, and then along the way I'm going to discuss what I think is kind of a controversial topic, at least from what I've seen in discussion forums and comments and in my channel and other transmission builders channels when discussing 4L60E 3/4 clutch pack failure, and that is the load release springs, or sometimes referred to as drag springs, or anti-centrifugal apply springs. Many folks are under the impression that their usage is kind of either all or nothing. In other words, you always install them no matter what. Doesn't matter, what your setup is, what you're doing, what other factors to consider. Just install them and that's it. And then there's another camp that says that you should never install them. Leave them out no matter what you're doing. Doesn't matter. Just do not reinstall them. My posture is going to be that it's more nuanced than that, and the real quote-unquote truth lies somewhere in the middle. And so I'll talk through that as well, give you some tips and pointers, and things to consider, and situations where I would both install them, and then situations where I would leave them out. So let's get a little bit closer to the bench. We'll talk through all the different parts and components we have, and then we'll go through the stack up, we'll measure our clearance, and then we'll kind of summarize our findings and close out the video. Okay, as far as parts and components individually are concerned, everything to the left of the load release springs are factory, everything to the right is aftermarket, and other than the Sonex springs, everything else as far as snap ring, clutch and steels and backing plate, that's what comes from the package from Alto in their power packs. So we're going to demonstrate the 4L65E stack first, so I'll just walk through that. So you can readily identify an apply and a backing plate that went into a 4L65E 3/4 pack by looking for the letters HD stamped into each part. Okay, now these measure 148 thousandths of an inch thick on the backing plate and 215 thou thick on the apply plate. Now these two particular examples are burned. I would never use them other than in videos and for reference. Okay, as far as the module itself, you have 7 friction plates and 6 steel plates. The clutch plates are going to be 68 thousandths of an inch thick, and your steels are going to be 96 or 97 thou of an inch thick. Okay, so 7 and 6. By comparison, a standard 4L60E stack is going to be 6 and 5. So standard 4L60E apply and backing plates are going to be 175 thousandths of an inch thick on the backing plate and 224 thousandths of an inch thick on the apply plate. Otherwise, same design. Alright, now snap rings for this clutch are not supposed to be selective, and an overwhelming majority of them are going to be somewhere between 93 and 95 thousandths of an inch thick. However, I have come across some that are a little thicker. I want to say 100 to 101 thousandths thick, and 82 or 83 thousandths of an inch thick is what I remember seeing, and I believe I actually have some of those, but they're in the drawer and it would take a while to dig them out. Okay, I also have some steel plates. This is a 4L60E spec steel, 106 thou, and a 76 thousandth of an inch thick steel for 700 R4. Finally, for factory parts, I have some additional apply and backing plates. So here we have a 2-piece apply plate setup. This is from a 700 R4. So you have your support and then the apply plate itself. And these are, let's see how thick. So this one looks like it's 165 thousandths thick. And then this is a backing plate. And I believe this is actually aftermarket. And this is 130 thousandths of an inch thick. Alright, so just from the factory alone, you have a lot of different options to configure your clutch and dial in your clearance. So consider everything selective. Clutch plates, 4L65E 68 thousandths, 4L60E spec, I want to say is 82 or 83 thousandths, somewhere in there. And you can mix and match between the two to get your clearance. Alright, if anybody tells you that you can't mix and match frictions, as long as they're, you know, new or in very, very, very like new shape, good shape, and they're designed for that transmission, that clutch, you can do that. Okay, you can mix and match backing plates if you needed to run a 4L60E spec apply plate, but maybe a 4L65E spec backing plate. Again, to dial in your clearance, to do what you want to do, then by all means go ahead and do it. Alright, let's talk real quick about what Alto provides you, and then I'll start discussing dialing clutch clearance and talking through considerations on when and when not to use these load release springs. Okay, so Alto Power Pack. Alto provides 4 different parts and components within, within their packaging. You're going to get a 62 thousandths of an inch thick snap ring for the clutch. You're going to have 130 thousandths of an inch thick backing plate. Okay, this is designed to be used with the factory apply plate. And then for your frictions, they're going to give you a total of 9 clutches, all 62 thousandths of an inch thick. You're also going to get 9 steel plates. So So there's 7 here in my hand, plus these 2 here on the bench. They are 60 thousandths of an inch thick. They will also give you a selective steel plate that's 80 thousandths of an inch thick. So if you need to, if you're a little bit loose, you can swap in the 80 thou thick for one of the 60 thou thick plates and dial in your clearance, tighten it up. Now, if you need to do that, this should be on the very bottom. Okay, you'll have your backing plate, or excuse me, your apply plate, your first friction, and then this steel, and then your second friction, and then the rest of your 60 thou steels. Finally, your backing plate and your snap ring. All right, so let's talk about load release springs and when you should use them versus when you may be prudent to leave them out. So for load release springs, anytime clearance is tighter than 35 thousandths and 40 thousandths really in high performance, I will install the load release springs. Okay, it is not a one-size-fits-all, install them no matter what. This is based on my own personal experience building well over 1,000 700R4s, 4L60Es over my 12-year building career, using a variety of different configurations, learning a variety of different lessons, some the hard way. That is what I found to be prudent to do and to work. So the load release springs prevent centrifugal apply when you're in first and second gear, especially at high RPM, because the return spring assembly for the 3/4 clutch that sits just on the inside of the 3/4 ply ring is relatively weak. So these springs act as additional buffers between the applying backing plates and the clutch pack, preventing it from dragging. Now, if your clearance exceeds 40 thousandths and you are building a transmission for a factory application or even a mild performance application where the vehicle is never going to see more than 5,000 RPMs, or at least it's so rare you might as well say never, then you can go ahead and leave these out, because once the clearance starts to open up, especially in your between 50 and 60 thousandths of an inch, you're not going to drag at lower to normal RPMs, say 3,500 RPMs or below, 4,000 RPMs or below. The clutches will not drag. So at that point, the additional force required to compress these load release springs and apply that clutch becomes more of a hindrance. It becomes kind of like a roadblock or a barrier to crisp clutch apply. Now, I think it takes roughly 10 psi marginal line pressure to apply the clutch with the presence of the load release springs as opposed to not having them in. So that can easily be compensated for by updating your boost valve, which is something you should always do in these transmissions. Sonics or Transgo, and I think there's a few others. Drilling out your 2-3 feed orifice in the spacer plate for all 4L60Es. This is what I recommend. Drill your spacer plate as follows: 93 thousandths on the 2-3 feed, 93 thousandths on the band release, 93 thousandths on the 3/4 feed, and if your vehicle is like a heavy duty towing, working, hauling, 86 thousandths on the low reverse feed. I do not recommend you drill the 1-2 feed unless you're racing and you're working with a stall greater than 2200 RPM. That's just my own personal experience, as well as tons and tons of feedback gathered from customers in the transmissions I built, especially if you're running a Corvette servo. So the 1-2 shift can be very problematic if things are not done exactly right. And that means a combination of serviceable parts, including the valve body, as well as mechanical calibration and adjustments made to the 1-2 circuit, particularly the 1-2 accumulator regulation. So I don't want to make this video about that. If need be, I'll discuss it in more detail in another video if there's enough demand, but suffice to say, I would leave the 1-2 feed alone, especially if you're running the vet servo and you're working with a factory stall converter in a non-high performance, non-heavy duty application. If it's heavy duty, go ahead and drill it to somewhere between 76 and 85 thousandths. If you're at 2800 stall and you're running a vet servo, 80 thousandths is a good feed hole size. If you're running a Superior Tech Super Hold or Sonic Super Hold, keep it at 70 to 76 thou. And that's all I'll say about it for now. All right, let me move the camera over and we'll get you a bird's eye view over the clutch drum, and we'll stack up the 4L65E pack and see what kind of clearance we have. Okay, let's go ahead and stack it up. So again, we have our 7 clutch plates and 6 steel plates. Our apply plate, so that's going to go in first, 215 thousandths. Clutch steel until you run out of them. Okay, and if you don't know already, these 2 tabs here go in the wide cutouts in the drum. Some people say that it's best to kind of scruff up the Lindert or Colleen steels. I've never actually done that. I've never found it to be necessary. I just install them as is. But I know several builders, and when I say builders, I mean like, you know, prominent voices and names out there, you know, across the country, have stated that they like to do that. All right, so we have our stack up. Now, if you want a good indicator as to where you're likely to be, assuming you know, you're using like kind parts, is when you have your backing plate installed, you should see the backing plate roughly in line with the bottom of the lug here in the snap ring groove on the you know, on the drum. So we're going to use our factory 93 thousandths thick snap ring and see what this gives us. Okay, now leave the load release springs out for the purposes of clearance measurement. Get you zoomed in so you can kind of see. Now, I use shop air with a dial indicator to measure all my clutch pack clearances, but if you don't have an air compressor and or an indicator, then you can use feeler gauges. So I'll demonstrate, I guess, just for the sake of doing so, since this is a demonstration. So what I'm going to do is, just by eye and by feel, this looks like between 30 and 40 thousandths to me. So I have a 30 thousandths thick gauge. I don't know if the camera's going to pick that up or not. There we go. And how I measure it is 180 degrees out from the snap ring. Alright, so here's our snap ring, and so it's going to be right around a 4. Okay, so I'm able to get it in. I would recommend you compress the pack a little bit, but don't get crazy with it. So it's a tight fit, so that tells me we're probably below 30, at least as measured with the feeler gauge. Okay, tight fit. Now you're going to have a looser fit by the 2 ends of the snap ring. I mean, that's always going to be the case for obvious reasons. So that's why I don't measure it over there, and I try not to be within 90 degrees of it. I'll go 6 o'clock, maybe, I don't know, 3 o'clock, 3:30, and 8:30, 9 o'clock, if I'm doing feeler gauge. All right. So like I said, this felt between 30 and 35 thousandths. Now, one thing to know, and this is what I've learned when using feeler gauges, is that they tend to understate the clearance by about, I would say maybe between 10 and 12%, at least with this clutch pack. Okay, it's going to vary based on whatever unit you're working on, whatever clutch, but I found that the dial indicator and the compressed air is a lot more accurate. Now, one last tidbit I'll leave for consideration before we actually do the measurement is that when you stack it up dry on the bench like this, and whatever your reading is, let's just say we'll call it X. If you were to pull this transmission apart after, I don't know, let's just say 1,000 miles on the road, and measure the clutch clearance as it comes out of the unit, you know, just the same way you did before in the exact same locations, you will find that your clearance will have experienced some growth. Anywhere from between 3 and 7 thousandths is what I've been tracking over the last few years that I've started keeping track of it. So keep that in mind as well. Once the clutch starts working in the vehicle, things tend to loosen up ever so slightly. So when it comes to clutch clearance, I like to be on the lower side of spec. Okay, as long as I'm within spec, I'm good. So especially if you're working on something like a 6, 8, or 10-speed transmission, they're all clutch-to-clutch units. Clutch clearance is absolutely paramount of importance when it comes to the function and operation of those transmissions. You don't have anywhere near the amount of margin for error for them that you kind of do for some of these older units. Like 480Es, for example, you could be almost all over the map and still be okay within reason. With a 6L, you try that. If you're just 5 thousandths, 7 thousandths under spec, you're going to have temporal tie-ups with that thing. Okay, we have our dial indicator handy here. It's not quite set up yet because before you take a measurement, you want to just work the clutch pack. Just put air into the circuit and get it moving so that all the parts can kind of settle in together, so to speak. I don't know if that makes a huge difference, but I found that, if I do that prior, I see less variance when I actually measure the clutch pack multiple times. I guess take it for what it's worth. So your 2-3 feed is going to be the bottommost apply circuit port on the turbine shaft. And all you're doing is trying to move the clutch. Alright, the air you're hearing is coming out of the nozzle because I have barely enough room to get the nozzle on that little feed port. So, alright, now we'll go ahead and we'll move the indicator into position, get it set. And again, I'm roughly 180 degrees out from the ends of the snap ring. So let's see where we are at. Alright, so we're at 20 thousandths. And, that kind of rings true based on what we were seeing with the feeler gauge. I was having to damn near force it underneath the snap ring to get it to go. So what we really need to do is create 10 thousandths worth of space. And this sometimes happens. It happens due to a combination of tolerance stacking, right? Or I should say a combination of parts that have slightly different dimensions, as they come off the assembly line. And all that variance kind of accumulates, and if everything's kind of on the larger side, you'll get kind of a very tight clearance measurement like what you see here. Now there's one part that I haven't mentioned in here yet that also plays a role in the 3/4 clutch clearance, and that is the 3/4 apply ring. I mentioned it in passing, but I didn't touch on its importance when it comes to, and the role that it plays when it comes to determining your 3/4 clutch clearance. So you have 3 different apply rings from the factory. Alright, you're going to have an unmarked apply ring. Okay, and when I say unmarked, I'm looking for a number stamped right here on one of the shoulders, on one of the legs, or arms. Okay, the unmarked apply rings are from 700 R4s, mostly early 700 R4s, 82 to 86. If you see a number 4, okay, number 4 apply ring, that's from an 87 through 93 700 R4. And if you see a number 7, that's going to be all 4L60Es. So the number 7 has the shortest legs, the number 4 is kind of in the middle, and the unmarked apply ring has the longest legs. So the longer the legs, the tighter the clearance, and the clutch for the 3/4 is going to be, all other things equal. All right, so this is kind of why you want to have different thicknesses or different dimensions of the same part on the bench when you're doing this, especially with these 3/4 clutches. So what we're going to do is we're going to take out a 4L65E steel plate, and we're going to install a 700R4 steel in its place. And we're going to see what we can come up with. Okay, so we're just shy of the lug there, the top of the lug, relative to the top of the backing plate. I gotta install this so that I want the ends 180 degrees relative to the dial indicator. I normally would never install it like this, but you know, that's why it's a little awkward. Okay. All right, let's give it another go. Okay, I had to move the drum because I lost my feed port, or lost access to it. Alright, so it looks like we're at 42 thousandths. So 42 thousandths for a factory application, I would still install the load release springs. You know, we're on the looser side of tight, but I wouldn't want to take a chance, especially if it's 700R4. And that's because I think that the return spring assembly for the 3/4 pack or 3/4 apply piston is a little bit weaker than the 4L60E, but regardless, I mean, it really doesn't matter. At 41 or 42 thou clearance, I'm installing the load release springs because I want to make sure that there's no drag occurring in this clutch. So if this was going to be the clutch pack that I was going to run with, then I would consider this done. I would install my load release springs and I would move on to the next step, whatever that might be. Okay, now what we're going to do is go ahead and stack up the Alto power pack. Now, if you wanted to be super diligent, you'd want to measure, or take another measurement rather, about 180 degrees offset from your first measurement and then average the two. I mean, that would be the technically correct way to measure your clutch clearance. I'm just not going to do it because of the sake of time and access relative to where the camera is. Okay, so the components we're going to use from Alto are going to be the 9 frictions, our backing plate, 130 thou thick, our 62 thou thick snap ring, and I'm going to start with the steel plates, all of the 60 thousandths of an inch thick steel plates. And then if we need to, we can go ahead and swap in that 80 thousandths thick plate if clearance is a little on the loose side. Alright, so we're going to use our factory 4L60E spec apply plate, and then we start putting in our clutch pack. So clutch, steel, clutch, steel, clutch, steel, clutch. So you're all out of clutches and steels, and then your backing plate. So like I said, this is going to be the clutch that we actually run in this transmission. It's a 2004 model year 4L60E going into an 05 GMC Sierra. And It's a 4x4 vehicle, does some towing and hauling. So we're doing this plus a few other upgrades. In fact, I don't want it there. I want the snap ring ends over here so that I can put the dial indicator there. So again, got to install this much differently than how I would normally do it. You just saw how I would normally do it. So it looks like we're going to have a little bit too much clearance, I think. Maybe. We'll see. Probably shouldn't just blindly speculate. Alright, that's roughly 180 degrees out. Alright, but since I'm engaged in speculation already, I might as well just guess the clutch clearance. I'm going to say we're probably about 50 to 60 thousandths based on what I'm saying. Maybe more. Oh, that's even worse. That's 86 thousandths. 80, or no, hang on. That's 91 thousandths because we're returning below zero. Alright, so 91 thousandths, we have quite a lot of ground to cover here and to make up. So, a couple approaches we can take. We know we're working with 60 thousandths of an inch thick clutch plates. We also know we have 60 thousandths of an inch thick steel plates. So we have the 80 thou thick steel, and then we also have a 106 thousandths of an inch thick steel. So if we know we're working with 94 thousandths, and let's just say we want to get down to 40. Okay, if we add 40 thousandths of thickness using a factory spec 4L60E steel plate, we can subtract that margin. That's what, 106 from 60, so that's 44 thousandths. I'm screwing this up. So that gets us to 50 thousandths. If we want to get down to 30, then we can further swap out another 60 thousandths of an inch thick steel plate and install that 80 thou thick. So let's do that. And that will give us to 30 thousandths. And let's see what that yields in reality. And I say that because a lot of times when you do the math, the relationship isn't purely linear or purely mathematical. Sometimes when you measure, you find that it's, you know, either a little bit less or a little bit more than what you calculated. So here's the first 60 thou steel that's going to come out, and we're going to install a 106 thou steel in its place. Okay, and here's the next 60 thou steel. And that's our 80 thousandths selective from Alto's kit. So as you can see, if we only had Alto's components to work with, we would probably be in excess of 50 thousandths of an inch. Probably. Alright, once I get this dialed in, I'll actually simulate it here, demo it, and see what we would come up with if we only had Alto's parts. at our disposal. Okay, this feels a little tight to me, so we may end up doing that out of necessity anyway. So started at 94. Let's see where we are at now. Okay, it's returning to 1 below 0, and it's not quite getting to 40 thou, so I'm going to say this clutch has 40 thousandths worth of clearance to it. And that's where I'm going to leave it, but let's see what would happen if, you know, all we had was what came in the package from Alto. Because remember, these kits are supposed to be standalone, such that you should not need anything else other than the factory apply plate to make this work. Okay, so we're gonna take out for the moment our 106 thousandths thick steel plate, and we're only going to use the 80 thou thick plate. And then our clutch, and then a 60 thou thick Alto plate, and the rest of them are all going to be the same, 60 thou thick. And there I go again. I forget. I want the rings at the ends rather, at the 6 o'clock position. And it's like I gotta overcome my urge to install the snap ring as I normally would, because I don't want to install it in this kind of awkward way. Okay, do the best you can to get the dial indicator, you know, perfectly vertical. I mean, if it has a slight cant to it, that's not going to make a difference. But if it's like severely canted, angled, you know, off from 90 degrees perpendicular, then your measurement won't be accurate. I got to double check it again because I got to create some space for my nozzle. Alright, I think I need a new plunger as well. I think that one's slightly bent out of shape. Alright, let's see what we would get in the event we were only working with Alto's parts. Alright, it seemed like that clearance went up, but I think that's more to do with my dial indicator. Okay, let's see. All right, so that tells us that we're way out. I mean, with the factory spec, they tell you up to 83 thousandths is acceptable. In my opinion, that's completely wrong. I mean, this clutch has 83 thousandths clearance. That's way too much. All right, if you check out Alto's website, they do have instructions available. So we are using the, I mean, they got like 4 different setups for 700R4s using their number 7 apply rings, and then here's for the 4L60Es, and then this is with a 700R4 with a number 7 apply ring, and then they got different apply rings, and that's why I wanted to make sure I mentioned them, you know, and pointed out the differences prior to looking at the instructions. So they also have one-sided Red Eagle friction plates, and then I think they have a couple other options here for you as well, along with some guidance. I'll put the link in the description to these instructions so you don't have to go rooting around for them. This is more or less just to show you what is available. You know, if you buy the power pack individually, it'll come with a folded up version of these. If it comes part of like a deluxe kit that's sold by Transparts Warehouse, then there's no instructions included. You just go to the website. But here's the clutch clearance. It should be between 35 and 50 thousandths of an inch. That's what Alto's telling you. So if we only had to resort to what Alto had provided, we'd be about 30 thousandths greater than the max spec. Okay, gotta dig out the clutch again, reinstall our factory 4L60E spec, and then install our 80 thou selective plate from Alto, and then stack the rest of it up. Okay, right back at the, you know, being flush with the bottom edge of the snap ring groove. All right, we're right back where we needed to be. I know it was returning to about 91 thousandths, in other words 9 thou below zero, and it was coming to about 34 or 35 thousandths. So that tells me that we are at 40 thousandths overall dry clearance. It's probably going to grow to about 45 thousandths clearance once this pack goes back in and starts working, you know, vehicle starts driving again. So that that's acceptable for me. For a working vehicle that's going to be doing some towing, some hauling, I think that we've set this clutch pack up for success. Let me briefly summarize what we've done here, and then I'll talk a little bit about the 3/4 clutch pack in general. So we've shown you 2 different setups for an upgraded 3/4 clutch pack, one from the factory, the 4L65E, and then one from Alto, and we had to make adjustments to both clutch packs. We did not install as is, or you know, as intended out of the box. So just be aware of that when you're building these and you're deviating from the standard 6 and 5 for 4L60Es and behind V8 motors. You may have to do some, you know, swapping, some adjustment with different selectives to get your clearance where you need it to be. And a selective is by definition anything that is considered to be an identical part but slightly different dimensions for purposes of adjustment of a specification, in this case clutch pack clearance. So Yeah, we showed you the 3 different apply rings that come in these drums. As far as I know, there's not a 4th, but I certainly could be wrong. I'm very, very unfamiliar with the small displacement V6s, the transmissions that came in behind the 60-degree V6 engines, for example. Those were all 700 R4s, and then I think the 3.8 liter V6s or 3.4s that were put into things like Camaros and Firebirds in the 90s that took 4L60Es. They had, I believe, 1 less friction and steel in the 3/4 clutch pack. But like I said, I haven't done one of them in ages. Very rarely do I ever see them. So all of my content here applies to 4L60Es that went in behind the Gen 1 small block and Gen 2 and Gen 3 / Gen 4, I think technically, small block Chevy engine families, including the 4.3 liter V6s, both variants, Gen 1 and Gen 3, or Gen 4 rather. So as far as keeping the 3/4 clutch pack healthy, clutch clearance is really only a small part of it. You want to make sure that the drum itself is in good condition. It's not leaking where the input shaft is pressed into the drum. So if you're familiar with my teardown inspection videos or the standalone video where I talk about and demonstrate pressure testing this drum, you put a little bit of fluid here at the base of the shaft, and you put air into the different feed ports. Here, this is going to be your forward feed, this is going to be your coast clutch feed, coast clutch, then this is going to be your 2-3 feed, and you're going to look for bubbles in this area here. Bubbles coming up from where the shaft is pressed into the drum. So because you have a steel shaft pressed into an aluminum drum, there's always propensity for asymmetrical wear, different wear rates because of the different materials, aluminum being the softer material. And so you always want to check that. The other thing is just general management of drag. So if you're going to run Transgo's high rate return springs, they come with a different bleeder orifice, and you would install that bleeder orifice in place of the factory orifice. Otherwise, just check this ball in here, make sure it's moving, and make sure it's working. If it's moving, you can hear it, then you know it works. Okay, third is your sealing rings. Always, always, always replace these sealing rings on overhaul. Never reuse them. I know some guys like to reuse sealing rings. It never made any sense to me, to be honest. So you have a total of 4, 1 here, 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 and here. These 2 sealing rings are for your 3/4 apply circuit. Make sure the valve body is in good shape. Make sure the pump is in good shape. The pump has to have proper clearance. The pressure regulator valve and boost valve must be holding sufficient vacuum when you go and do your vacuum testing. I have videos that show you exactly how to do that. So between that, the drum, the clutch pack clearance itself, the materials used, the parts used, and calibrating your 2-3 shift appropriately for your application, all of those things go into ensuring that your clutch pack is healthy, that it's set up correctly, and that it will survive into the depths of time. In other words, hundreds of thousands of miles. Okay, at very minimum, you should get 100,000 miles out of a 4L60E rebuild if it's done right, at very minimum. 150 thousandths is a good expectation. 200 thousandths is kind of like at the upper end. If you get 200,000 out of a rebuild, that's excellent. But at bare minimum, you should have 100 thousandths. And in a factory or otherwise mild performance application, high performance, a totally different ball game. The transmission becomes like a wear item, and you periodically pull it for refresh. I mean, that's just the way it is. You got to pay to play, so to speak. All right, that is the video. Thank you so much for watching. If there's any questions you have, any comments or feedback, go ahead and leave them below. If there's anything else you want me to touch on with 4L60E, 700R4s, I'm always building these transmissions, so I'm always going to be doing videos. Go ahead and post it, and I will do what I can to prioritize it for a video as soon as I can. As always, thank you so much for watching. Enjoy the rest of your day or evening, and I look forward to seeing you on the next video.